All right, welcome back. So our last topic here in Unit 8 is the idea of classifying conic equations. So we know we have our circle, we have our ellipse, hyperbola, and parabola. So now what's going to happen is I'm going to give everyone what's called, we've kind of worked with this already, the general conic equation, which is this formula right here, ax squared plus bxy plus cy squared plus dx plus ey plus f equal to 0. We have not yet dealt with the bxy expression there, because if it's not 0, you have what's called a rotated conic equation. Something that we're not covering in this class in terms of graphing or writing equations with. But we can classify with it if I give you a BA term in there, and it's what's going to, we'll go through that process. So the way we classify is you're using what's called a discriminant, which you should recognize from your quadratic formula. It's your b squared minus 4ac. And it turns out if the discriminant is negative or positive or 0, you can classify each shape based on that. Where they're showing us here when it's negative, there's two possibilities. Either it's the circle or the ellipse. To be the circle, if it's going to be a negative value, b has to be 0 and a and c need to be the same number. Whereas if it to be an ellipse, you either need it to be b not to be 0 or a and c can't be the same. Either one of those options. So if you have a b value that's not 0 and you get a negative, it's guaranteed to be the ellipse, regardless of what's happening with a and c. Whereas if b is 0, then you need to have a and c to be different numbers for it to be an ellipse. For the parabola and hyperbola, it's straightforward. If the discriminant is 0, it's always a parabola no matter what a, b, and c are going to be. And the hyperbola, it's always positive for that discriminant. So you'll notice the d, e, and f terms don't actually matter for the classification. It's only about a, b, and c. So when we're classifying these things here, if they're not rotated, it's generally pretty straightforward. Like you can look at this kind of go, okay, so there's clearly nothing in front of x squared and y squared. They're both positives. This is clearly going to be a circle. But for our classification purposes, we're recognizing a is 1, the coefficient of x squared. There is no xy term, so b is 0. And then c is always the coefficient of the y squared term, so c is 1. So when we do our b squared minus 4ac, we get negative 4. Since it's a negative, it's either a circle or an ellipse. Since b is 0 and a and c are both the same number, this would be our circle. So for our classification purposes, I'm always going to require you to write out what the discriminant value is, in addition to telling me what type of shape you're dealing with. So make sure you're doing your simple b squared minus 4ac each and every time. All right, so here's a bit more going on. We can clearly see, though, again, it's not rotated. There's no xy term. X squared and y squared are different numbers, and one of them is negative. This is definitely a hyperbola. But showing that a is equal to 4, b is 0, c is negative 9, 0 squared minus 4 times a negative 9. Doing that gives us 144, and it's positive. Because it's positive, that's how we know we have an hyperbola. The next one here, we can clearly tell this is going to be an ellipse because we have two different values for our x squared and y squared terms. There is no xy term as well. And again, they're different. They're both positive. So that's going to be the ellipse, but showing that with our discriminant, a is 2, b is 0, c is 1. And again, everything else we really don't care about. We can almost just ignore it. It's not relevant to the actual portion of the classification. So 0 squared minus 4 times 2 times 1, we get a negative 8. Negative value. A and c are not the same number, so therefore this is the ellipse. And then finally, the parabola, you'll be able to easily recognize because there's going to be a missing squared term. There is no x squared term in this problem, or if there was no y squared term, then that's always the parabola. But for our classification purposes, a is 0, b is 0 because there's still no rotated portion of that, and c is going to be a 1. 0 squared minus 4 times 0 times 1 gets us 0, and that's why it's the parabola. So obviously classifying when it's not rotated is very straightforward. There's not too much to it. You can pretty much visually look at it and just know exactly what it is. The discriminant's only necessary because I'll be asking for it as part of your questions that you'll need to give me. Now, where you need to start being careful with, though, is when we start including the xy term. Because the rotated conic is one that's no longer parallel to the x or the y axis. We're not writing the equations of them. We're not graphing them. We're only going to be classifying them. That gets into a little bit more information that we need to really worry about for the purposes of our class. So we can clearly see there's an xy term here. So you might be tempted to go looking at, if you see just, okay, it's 2x squared, 2y squared, they're both positive and they're both the same, therefore this has to be a circle. But the negative 3xy in the middle is going to kind of change things up a little bit. First off, for the rotations, it can only ever be an ellipse, parabola, or hyperbola. The circle is never going to be a rotated conic, because if you think about a circle, you rotate the circle, literally nothing changes about it. That's what a circle is. It's the other ones when you rotate it, like, for example, the parabola, like a vertical parabola would look like that. A rotated parabola, so it would have a rotated axis frame, so it'd be like here, would then look like this instead. So it's obviously a completely different kind of thing. It's half vertical, half horizontal. So that's why it matters, but with the circle, nothing changed about that. So anyway, back to the classifying. So A is going to be 2, B is going to be negative 3, and C is also going to be 2. So we'd have negative 3 squared minus 4 times 2 times 2. So we'd have 9 minus 16, which is negative 7. It's negative, therefore this is an ellipse. But again, not a circle, even though A and C are the same. It's an ellipse. Can't be a circle if it's rotated. So for this one right here, we can see that, okay, so x squared and y squared are both positive and different numbers. So again, without the rotated, you'd be saying, oh, this is going to be the ellipse now. But again, with the rotated, things are going to change a little. A is 1. That's what's in front of x squared. B is the negative 6 in front of the xy term. And C is 9. So if I filled it into my b squared minus 4 times a times c, we actually get 0. So this would actually be a parabola if we were to go through the process of figuring out the rotate equation format of this thing and plotting it out and doing all that stuff. This actually creates a parabola shape because the discriminant is simply 0. So you cannot just simply trust how it looks visually anymore like we did when there was no xy term. You have to actually go through your full discriminant process. And so for this one right here, so clearly this one's going to be a hyperbola because I've done an ellipse and a parabola here, so this one has to be the hyperbola. But you're looking and going, there's no way. X squared, y squared are both positive. They're both different numbers. In fact, the xy term is also positive. How is this going to be a parabola here? Well, we go through our calculation. A is 3, B is 8, C is 4. 8 squared minus 4 times 3 times 4. 8 squared is 64. 4 times 3 times 4 is 48. We get a positive 16. And again, positive discriminants always mean hyperbolas. So we no longer need to have either A or C be negative to cancel out the minus 4 portion of the problem and make it a plus sign there because we have the B value. So if the B squared is larger than whatever 4 times AC is, it's going to always be a hyperbola. So I can have everything be positive. All right, so make sure you're careful. Make sure you're always calculating out your discriminants. If it's not rotated, again, like we were kind of talking about, you can get away with just kind of visually classifying it without finding the discriminant unless the directions for a question explicitly says find the discriminant value. But for the rotated ones, if you just visually look at it, you're going to get all sorts of messed up. You're going to have to calculate something out. Even if you're doing the discriminant in your head calculation, you still have to calculate it out. All right, so that's it for our conic equations. Next up, Unit 9, we're going to talk about matrices and how we can use those to solve systems of equations for the most part. All right, so I'll see everyone next time for that.